In this video, I want to give you a short review of the definite integral, what we discussed in class. And then I'll follow up with a few examples in the next videos, okay? So I want to remind you the Riemann sum. So given a function y equals f of x defined on AB, the function doesn't have to be continuous, it doesn't have to be positive, we just want it to be defined on AB. The Riemann sum is this summation. The sum of f of xi star times delta x. Well, what's delta x? Delta x is b minus a over n. Well, how do we get the xi stars? First, we build x's. So xi is a plus I times delta x. These are x1, x0, x1, x2, up to xn. These are partitioning the interval AB into n subintervals. So I have the interval AB. I can then partition that into n subintervals. And then pick x1 star in the interval x0, comma x1 in the first interval. And you continue to pick the same in each interval. In the ith interval, you pick xi star, and so forth. And then you calculate f of xi star multiplied by delta x. And that gives you the Riemann sum. So the Riemann sum is just this sum. So we can do the left sum or right sum or midpoint sum. That's what we discussed in class. Now, the definite integral this time is the integral from a to b of f of x dx. That's the notation. This is just the limit of this Riemann sum as n approach to infinity, I from 1 up to n. This idea is if you divide the interval into n subintervals and get n larger and larger and larger and larger, that's, and as n goes to infinity, we get this definite integral. What does that give us? Well, say we have a function f. Suppose it's just a nice and continuous function, but somehow it has some positive and negative values. So let's label this as positive areas, and label this one as a negative area. So A2 is a negative value, is the area. So this is your x-axis. A1 and A3 are positive areas. So the integral from A to B, here is your A, here is your B, this is y equals f of x. The integral from A to B of f of x dx is actually the net area. This is actually A1 plus this negative value A2 plus a positive value A3. Okay? So that gives you the net area. That's what the limit approach to. That's what the integral is. This is the definite integral. So one thing we looked at is if f is a positive function, then this gives you the area under the curve. If, let's say, f is a velocity function, if v of t is velocity of a moving object, on a straight line, So the velocity could be positive, negative, 0. And when you integrate from a to b of v of t dt, is what you get is the displacement of the object from time t equals a to time t equals b. In other words, you look at the object at t equals a, and then you don't care what it does, but then when you look at the object at t equals b, what displacement did it do? Okay, how much did it move? And that's this integral. So this integral gives you the displacement of the object from point t equals a to point t equals b. Sometimes gaining distance, positive distance, when the velocity is positive, and sometimes losing distance because the velocity could be negative. That means that the object might be going backwards. So that's just a quick review for the definite integral. And next I have done a few examples in class, but I will do 3 more examples in here.